Dimmi, è questo per parlare, per farsi sentire? Sì, sì, dimmi tu. Così diciamo, eh? Ok, allora, andiamo. Okay, good afternoon, everybody, and welcome to the first seminar of the 5th edition of the ESIC seminars. I'm Guido Zolezzi. I have the honor of being the chairholder of the UNESCO chair that you see in the logo of in Engineering for Human and Sustainable Development at the University of Trento. And I will very shortly recap what this series of seminar means, why we are repeating, we're, let's say, doing it now for the 5th year, consecutive year. So it's a cycle of seminars in which we wanted to screen sharing.
Yes.
Sure. Devo andare in Zoom?
Sì.
C'è uno Zoom meeting, ma non è ancora shared. Ok. Grazie. Forse lo schermo, perché poi dopo, così chi presenta non ha problemi. Okay, sorry for those who are online. I forgot to share the screen. Now you should see some slides that we are showing here in the room. So the UNESCO chair is a group of researchers, teachers, students, early career researchers, less early career researchers. And we are focusing mainly on the relation between engineering, and especially environmental engineering, and development. This was the main underlying theme of leading to the recognition also of the UNESCO chair 15 years ago, more or less. And you see in this arrow the same name of the seminars is Environmental Sustainability and International Cooperation, is also the same name that one curriculum of the Master in Environmental Engineering has, and this is not by chance, so it is, of course, our choice, because the UNESCO chair started when we were recognized by UNESCO this particular set of courses inside the Master of Environmental Engineering, focusing on the environmental engineering dimension in a cross-cutting way in relation to human and sustainable development. And after some years, we decided to organize a series of open seminars. Actually, it was the period of the COVID pandemic in which everybody was at home. So we started, I think, with webinars in the first edition. And then when it was possible to be again in presence, we started to organize them in a standard seminar way. So the aim of this seminar is to address these topics in a quite open format and trying to mix two levels of contribution. One is the scientific level, so bringing researchers to the webinars, and then the local experience of the local practitioner level. So we trying to bring as much as possible in the seminars both practitioners and scientists on the same topic. And we will see that this year we have 5 seminars. The first is today. You see here the type of topic. So we start today with nature-based solution in cities, and my colleague Davide Generetti will present the speakers of today. Later on, then we'll speak about pollution in agriculture, water and sanitation in sub-Saharan Africa, water quality in suburban settlements, and Earth observation and monitoring for space, oriented to environmental sustainability and international cooperation. A few bureaucratic formal information for the students who attend the seminar and will ask recognition of credits. So for students of DCAM, of whatever course in the DCAM department, to achieve the credit recognition, you need to have at least 80% presence. So please sign the presence. I don't know, I think there. Is the sheet that is there, correct? Yes. And then there is a final test, which will be basically a short presentation by each student. And each student will be asked to, based on the seminar that you attended, the topics, what was discussed, not only the presentation, but also the discussion, you will be asked to identify, describe, and discuss one particular challenge that is of your interest that came out from the topics. Could be also from different presentation, not only from one single one, even better if it's from more seminars, at least two, actually, as you see here, and try to bring together the technical, scientific, and the management implementation level, the same topic. So just present it, make a synthesis. It will be a 5 minutes presentation, so something quite simple, quite short, but the idea is that these seminars can be a kind of entry point for those who are not familiar with these topics and want to start know more about it. Maybe you are in the 3rd year of the bachelor or so, or for those who are already in the master, maybe to pick up some topic of interest that you didn't study in detail in the lectures, and can be a stimulus for you mainly. So, and with the same spirit, of course, we encourage a debate, a discussion. It's very open, and we hope this series will be a forum for establishing contacts, curiosities, knowing more about less known topics. And so, for all students who are from other departments, we can provide, of course, all the information on how the effort and the hours, topics of the seminar. You need to ask your study course council recognition of the credit. And I think I'm done. So thanks again for all those who are here, for those who are online. Thanks to the first speakers. We have Carlotta Quagliolo and Ludovica Dell'Armi, who graduated here, actually, but I will leave to Professor Davide Generetti introducing the topic and the speakers of today. Thanks to the speakers as well.
Yeah. Well, thank you, Guido. So very briefly, I'm glad to open this series of seminar with a topic that is quite important, both from a research perspective and from a policy perspective, and that has become increasingly under the lens of the policy agenda in Europe, but also elsewhere, as we will see particularly with the second presentation. So we try to address this topic from different perspectives. So first of all, nature-based solutions essentially are interventions aimed at protecting biodiversity, enhancing natural ecosystems, and at the same time addressing some critical societal needs, societal issues like poverty, like equity, like climate adaptation, like air pollution, and so on. And we are going to see how to address, how to discuss, to deal with NBS from two main perspectives. Our first speaker, who is Carlotta Quagliolo, sitting right there, Dr. Carlotta Quagliolo. She's a postdoc researcher at the University of Aveiro in Portugal, and she's currently visiting DCAM for this week and the next one, in case you want to catch up with her after the seminar. She will present her research on different perspectives for evaluating, for assessing the multiple benefits of that NBS can provide, particularly in urban settings. Then we have a joint presentation by Ludovica Dell'Armi and Adelaide Iucci, who are two very recent graduates from our program. They fall, actually, I think they attended the previous seminars of ESIC. They took this curricula, and they also attended the nature-based solutions course, of course. And unfortunately, they're not here. I guess they're very busy with their postgraduate career already. They will describe the experience in Chile that was conducted during their thesis to discuss different MBS to address challenges related to climate adaptation in different urban areas. And I guess they will also present a bit the project that was behind their research, and also the kind of involvement they had with local actors and local stakeholders. So let's give the floor to our first speaker, Carlotta. Guess you know how to navigate presentation.
Yeah, should be there in the desktop.
The floor is yours.
Thank you. So, okay, perfect. So everyone can see my presentation. Hopefully also for those online. Thank you for the presentation. And yeah, as already mentioned, I'm not going to get longer on the presentation of myself. I'm going to present a little bit, giving a little bit of overview about nature-based solutions and these multiple ecosystem services, values and benefits from nature-based solutions, and more like from the economic perspective, as my background is environmental economics. And then I will give you an application, actually is a recent research I'm actually working on. So I will start. As already mentioned, the big challenge of the 21st century actually is that global change that is characterized by three elements: population growth, mainly economic development, and climate change. And within this context, urban and peri-urban areas are actually facing significant challenges, as already mentioned, related to urban densification and urban sprawl, and also related to extreme weather events, connected to heavy precipitation and floodings, and heat waves and heat stress, and so on, habitat loss and fragmentation and biodiversity reduce, and so on. And in this context, nature-based solutions, sorry.
People from home, they are like seeing this part of the screen, but there's always an issue here. Maybe we can try this way. Sempre. Perfect. Probably if we
because maybe you have to share that screen, the second.
Just. How about now? Forse è bizzarro.
Forse devi condividere.
Ho fatto questa qua. Cioè sto condividendo.
No, no, quella lì, ma proprio con come presentazione, magari non sta bene.
Condividi.
Cioè, prima metti in presentazione.
Ok, allora prima. Allora, prima metto in condivisione. Non posso. Ah no, un attimo. Ok, vediamo solo così. Che adesso. Ora?
Sì.
Perfetto. Sorry.
Okay. So we were saying nature-based solutions represent the opportunity to actually make cities more resilient to this global change. They are, as already stated, they are inspired and supported by nature. And they basically provide, they can provide environmental, social, and economic benefits. So they are multifunctional. There are various definitions. There's not like one definition that you can use. I just can mention a few of the sources I'm more working with. The one from the IUCN that has more ecological vision, and the one from the European Commission of the same year that is more from the utilitarian perspective. And this benefits from human health and well-being. And then the most recent from 2022 from UN that is more combining these two perspectives. And the underpinning principle of nature-based solutions is that they are basically the operationalization of this multiple ecosystem services concept, which contribute to the social welfare and human well-being, social inclusion, and sustainable growth by providing a vast range of ecosystem services in terms of provisioning, regulating and supporting, and cultural services. This is basically a representation of that flow. I just all these terms I mentioned right now. So starting from the global change and the urban and peri-urban challenges, we have nature-based solutions, can be the opportunity and the solutions that provide various target and non-target ecosystem services and values that are influencing, impacting the human health and well-being in terms of key benefits and co-benefits that then can connect again with the global change through mitigation and adaptation connecting to urban and peri-urban challenges. And then why we want to give economic values to these ecosystem services, why it's important. Well, first to raise awareness about the value and the importance of the environment and that the environment has for us. And to inform and improve decision-making regarding the management of the environment, for example, and incentivize financial mechanisms for public and private investments, to reveal cost and benefits distributions of the implemented solutions, to internalize environmental externalities or to calculate environmental damages, and then set compensations or fees for using ecosystem services. There are various methods that we can use for valuing ecosystem services. Economists develop a range of primary ecosystem services valuation methods. Some of them are based on real existing markets, for example, market pricing or production functions. But as some of these evaluation methods that are based on revealed preferences, for example, travel costs or hedonic prices, that means that it's based on the actual behavior of people in actually using the ecosystem services to elicit the value of these ecosystem services. And then another category is about the stated preferences as contingent evaluation or choice modeling, for example, that are on the other side are based on surveys in which is asked to beneficiaries to define their preference on the use of a hypothetical change of the ecosystem services. And then there are another type of methodology that is called secondary ecosystem services evaluation methods. And in there we have benefits or cost transfer methods. And I'm going to focus more on this second category of valuation methods as most of the time. However, it's very important to have primary ecosystem services valuation methods. They are time-consuming and they require mostly high costs for implementation of these kind of studies. and to quickly provide information to decision makers. Very often is used this second type of evaluation methods. So benefit transfer methods is basically a procedure that is going to estimate the ecosystem services values of a current policy sites by assigning an existing value estimate for a similar ecosystem elsewhere that is from the study case. And in this, like a key challenge of this transferring of values is to keep into account the various differences among the policy and the study cases. And indeed, to transfer these ecosystem service values, we need to adjust these values considering socioeconomic conditions, the geographical conditions, and the ecological factors. And when to use this method, I already said his decision makers often require information quickly, at low cost, and at a wider scale. And they are also very useful for preliminary research and analysis. But there are, of course, some limitations, for example, related to the possibility of some inaccuracies of these primary ecosystem services valuations, for example, in some weak methodologies employed or unreliable data. And yeah, and also the availability of high quality primary ecosystem services valuation may be unrepresentative, for example, from a geographical perspective. We can have areas in which we have a lot of primary evaluations estimates and some that are not covered, but also from like a biomes perspective. Maybe there are more focus on wetland and forests and less on lakes and other biomes and ecosystems. Also limitation in the quality of the original data, and then limitation in this transferring process that can potentially result in an inaccurate ecosystem services value estimate, and that's called a generalization error. But also like we can have limits in temporal source, because the time, the value of estimated in some specific time, it can also change and cannot remain constant during the time. There are 3 techniques that can be used. The simple one is unit value transfer method. Basically transfer the value per unit, usually is per unit of area or per beneficiary. And then we have value function transfer, that is basically an equation that relates the value of an ecosystem services to the characteristics of the ecosystem and the beneficiaries of these ecosystems at the policy site. And then the meta-analytic value function transfer is the most complex one, and it's basically using, again, an equation estimated, but from multiple primary studies. There are various sources that can be used for having primary ecosystem services values estimates. I just reported 2 of them, Economic Evaluation Reference Inventory, but also Ecosystem Service Evaluation Database, ESVD, is the one actually I'm using mostly recently. And yeah, like if you're interested, I can give you some links. So now I'm going to present a little bit my last research. It's going to be an assessment of cultural ecosystem services and values from nature-based solutions, and the application is in the city of Aveiro in Portugal, and is a work in progress research. So we started with the idea that the presence of nature in some urban area it doesn't imply that this ecosystem services has a high value in terms of recreational opportunities, because that's highly connected to the possibility of people to access and have exposure to that nature. So we found that in literature, there are very few studies that are working on a spatial perspective on this kind of evaluation approaches. And because and modeling tools for this kind of recreational services assessment are very few, or like almost anything, and especially because that require a lot of information on population preferences, as I already said before, and in the primary evaluation studies, and on the uses of this urban nature. So there is coming the objective of these studies. It was trying to develop and apply a special environmental economic approach to assess these cultural ecosystem services and values from urban nature, to support the implementation of some nature-based solution scenarios. And that approach in trying to integrate the urban nature access model from the INVEST software and a meta-analytic value function transfer method into a spatially explicit environment. And the application is, as I said, the city of Aveiro. Specifically, I'm focused on a little area, the city center of Aveiro, and mainly because it's the urbanization uptake during this. The sources are quite old, 2012 and 2008, but it's still increasing. So we decided to focus on that area and see how. How much they need implementation of nature. And as I said, the environmental assessment was, we employed this model from INVEST. It requires various input data from land use, land cover, population per pixel, urban nature demand per capita, the decay function, and that is needed for the distance from the population and the urban nature, and a radius that is defined, a radius of distance that is defined in relation to each nature class we are going to assess. And all the input and output data are spatially explicit, and we work with QGIS. And the output we used is the supply of urban nature per capita per class that is expressed in square meters. And the 5 classes we use are forest, wetland, water, parks, and peri-urban. Then we start designing. We actually didn't finish yet, but we start designing the nature-based solution scenarios. And for the first 2 scenarios, green roof and bioswale, we decided to use the same simulation that we already used for another research in the past, as we can then compare the results. And for the last scenarios about urban parks, we actually follow one of the urban development plans of the city of Aveiro. For the economic assessment, as I said, we used a meta-analytic value function transfer method. The meta-regression model is coming from that Bokarayova, that is a study that work on this meta-regression. And the application of this meta-regression model was at global and European level, so quite wide scale. And it includes 60 primary studies, so it's not a lot, but it was what was so far. And that's the function, and with all the variables, and those in red So area, GDP and density was those variables that we could actually update with the local information. The output is the value of nature per classes in dollars per hectare per year. And we have these values for recreational services, aesthetic services, cultural heritage services, and then we sum up those 3 services as total cultural ecosystem services. And then we thought a way to try to integrate these 2 outputs in a special explicit way, because we wanted to see how these economic values can be connected to the supply of nature, so in relation to the population density. And we use that function to distribute basically the economic value. And here I will show you some results about the nature supply output for each of the nature classes we assess. So forest, wetland, water, peri-urban, and parks. And all these values are supplied per capita in square meter per pixel. And here are some results for the economic assessment. So it's the ecosystem services values for recreational, aesthetic, and cultural heritage. And here is the total assessment for the city of Aveiro. So that's actually the output from the meta-regression function application. And the values are quite high, and especially for parks, because it's the higher quality value for cities. And then, yeah, I will come to some discussion and conclusion. So that kind of integrated assessment using ecosystem services functions with a spatial explicit way, it can have a high potential, especially to support the implementation of nature-based solutions, because I didn't show very specifically in the output in the maps, but where we had all the red red colors actually was the part in which it almost like no values for the nature, the ecosystem services, and there can be areas in which we can think about some implementation of nature-based solutions, as for example, these scenarios for urban parks. And so that can really helps to prioritize the implementation of nature-based solutions. And there are for sure some limitations. For example, we only employ the nature supply maps, and also the area is quite small that we focus on because of this model that we employ to have the population density information. And also the meta-analytic value function model. It was what we found in literature, and it can have a lot of limitations. As I already said, so we are already working on nature-based solution scenarios assessment. We would like to think about more like a distributional justice in terms of access to nature, and we would like to integrate this analysis with the population by groups, for example, including some groups per age or like income or education. And we also would like to think about how to integrate then another output of the INVEST model that is about nature demand. It's not only giving nature supply, but also nature demand. That is the amount of nature in square meter needed by the population living in that pixel. But yeah, we still didn't think about how to do it, but it can be good for future development. And thank you for the attention. I hope that I was in time.
Thank you very much,
Yeah.
Carlotta. The idea is to have the 2 presentations first, and then a joint discussion and Q&A session. So I would like to ask Adelaide and Ludovica to take over Zoom at this point, which you already did, I guess.
I'm sharing.
5 years after COVID, I can manage the screen sharing and thing. Okay, can you try to?
I don't know if it's working.
Yeah, it is, and
Okay.
you need to do something. You have to do something now. It is full screen already. Okay, thank you. You can go ahead.
Thank you, Professor. Welcome everybody, and thank you for the attention. I'm Ludovica, and here connected with me there's Adelaide, my colleague, and we're about to expose our research thesis on the planning of nature-based solution, in my case to adapt to the flood risk, and in the case of Adelaide to adapt to the urban heat island risk. The project we took part is named FOVI, and it aims to contribute to the development of territorial plans to strengthen the Chilean region's resilience towards climate crisis, analyzing the magnitude of the risk and identifying the measures to adapt to this risk. This is an international project involving the Universidad Católica de Temuco as leading institution, other two universities in Chile, one in Santiago and one in Valparaíso, University in Mexico, the High Science Council in Spain, and the University of Trento. The reason why this study was located in Chile is that Chile was declared by the United Nations as one of the most vulnerable countries to climate risks, and especially the south central region of La Araucanía. This region, in fact, is marked by a very high social economic vulnerability level, also due to the high rate of indigenous people, and is marked by the occurrence of many hazards, among which mass removal, forest fires, water deficits, and flood and urban heat island risks. Our thesis specifically focused on the municipalities of Temuco and Padre Las Casas and addressed the issues of flood and urban heat island, since from the dialogue with the local communities and with local authorities, they emerged to be the most perceived and frequent risks suffered. Here you can see some pictures of the activities that we conducted there while our stay of 3 months in Chile. And now I will leave the floor to my colleague that will expose the methods applied in our thesis.
Okay, thank you. Moving on, the methodology followed in both research projects. As said before, Ludovica and I focus on the two environmental risks most perceived by local communities and authorities, the urban heat island and the floods. Regarding the topic of urban heat island, characterized by higher temperatures in urban areas compared to the surrounding rural areas, the objectives of the chosen methodology were to analyze this phenomenon in the literature, firstly, then study the current condition of the urban area, and then identify the most affected hotspots within the urban area. These hotspots are crucial for the future implementation of nature-based solutions as climate adaptation measures for the cities. To gain a more in-depth understanding of the current situation in the urban area of Temuco and Padre Las Casas, I conducted two different simulations. The first involved satellite images, and in particular the measures of land surface temperature data from the Landsat 5, 7, or 8 database, depending on their availability. Using this data, I developed a specific code in Google Earth Engine platform, and it was used to calculate the difference between temperatures recorded in the urban area and those in the surrounding rural area in a buffer 1 kilometer, like this map shows. And this calculation was necessary to identify for each of the 7 reference months the areas most affected by the urbanitarian phenomenon. In this slide, I put only two of the 7 maps provided by this type of simulation. The areas affected by the phenomenon were highlighted using a binary code, like we can see it in these 2 maps, where in red we have the location that experienced a heat wave in the reference period. By overlaying all the 7 maps, I created this final map assigning higher values to the areas where the phenomenon occurred over and over in time. To better understand the dynamics related to high surface temperatures, I also conduct a simulation of the current condition using the urban cooling model available in the Invest software. This simulation aimed to estimate the thermal benefits provided by the presence of green spaces and natural infrastructures, as well as the presence of more or less urbanized areas. The model is based on input data, such as the land use and land cover map, like the map in this slide, which classify the study area into different categories suitable for the simulation. In this case, I used a raster map with a high resolution of 5 meters per pixel. And then I use another important input data, that is the biophysical table, in which to each different class I assigned a specific value of such as shade, the albedo, or the crop coefficient. From these different input data and from this formula provided by the software, the Invest software, I obtained this final map as a result of the simulation that displaying the cooling capacity values for each of the pixel covering the total urban area. In red and orange, we can see the areas most affected by the urbanitarian phenomenon. Then overlaying the results from the 2 simulation, the satellite imagery analysis and the Invest cooling capacity model, I created a final map in QGIS that provides a more accurate representation of the hotspots, the areas most vulnerable to the urbanitarian effect. And analyzing all the obtained values, a total of 15 hotspots with the highest vulnerability scores were identified. We will see later the criteria used for the prioritization of these hotspots for the future implementation of nature-based solution. But now I leave the floor to Ludovica and the methodology used for the flood risk.
Thank you, Ade. And concerning the flood risk, the research questions that my thesis aimed to answer are here reported. First, to understand which is the magnitude of the flood hazard in the study area, so in Temuco de las Casas, and to understand which are the most affected areas. Then to understand how this flood hazard interacts with the vulnerability and the exposure to create the overall risk. And then to identify which are the most appropriate nature-based solutions to adapt to these risks. The flood risk assessment was conducted in accordance with the Intergovernmental Panel on Climate Change Report number 5, which recognizes the risk as the combination of three factors: the hazard factors, which is the probability of occurrence of the flood; the vulnerability factor, so the predisposition to be adversely affected by the flood; and the exposure, so the actual presence of people and infrastructure that can be damaged by the flood. This assessment was conducted firstly computing the flood hazard through the use of the INVEST urban flood runoff mitigation model of the Stanford University, which models the runoff phenomenon through the soil conservation service method. Among the inputs that are required, there's the land use land cover map. As already said, this is a raster map expressing the land cover classification depending on the land use of the soil. And this was built thanks to the information provided by the Agriculture Ministry of Chile and is the result of an iterative procedure. This map is associated with a biophysical table in which for each class defined by the land use land cover associates a curve number depending on the soil hydrologic group. This is the reason why we have 4 columns. And this curve number expresses the permeability potential of the soil. These curve numbers were provided by the HECRAS manual, but they were assigned thanks to an iterative procedure aimed at reaching the maximum correspondence with the real experience. And the last input is the precipitation depth. And in this case, we decided to run this model with 3 precipitation events, starting from a regular one with a return period of 1 year, up to 2 more critical ones with return periods of 5 and 10 years. Among the outputs provided, here we show the runoff generation map, showing the distribution of the runoff heights within the study area. And this shows how the maximum value of the runoff, that is 70 millimeters for a precipitation of 23 millimeters, is found in correspondence of the most impervious soils. And this map was used to build the flood hazard map, associating an indicator from 1 to 5 to the ranges of the runoff depths. Then, after the hazard, we processed the vulnerability factor, processing information, socio-demographic information provided by the 2017 census on age, gender, education, water access, and materiality of the housing, and even material status. They were associated with a vulnerability indicator, even in this case, from 1 to 5, from a very low vulnerability to very high vulnerability, depending on the criticality towards the flood risk, as in this case is shown for the wall material. And each of these criteria provided a map of the distribution of this indicator. All these criteria were combined together into a composite indicator through a weighted linear sum, creating the overall vulnerability map, showing which are the most vulnerable districts of the study area. For the exposure factor, basically we applied the same methodology applied for the vulnerability. And in this case, we considered the human exposure in terms of total population and population density, and the infrastructure exposure in terms of total infrastructure and infrastructure diversity. So considering how many different infrastructure were present in the same district. Even in this case, we associated an indicator from 1 to 5 to each of this information, and we created this map. They were again combined together in this case through a double weighted linear sum to create the overall exposure map, showing which are the districts in which there are the most people and infrastructures. These 3 maps that we have just seen were combined together through, again, a weighted linear sum to create the overall risk map, enabling the identification of the most affected areas for flood risk, and so to be prioritized for intervention planning. In this case, 27 planning options came out, and they were further reduced to 5 according to these 3 criteria. First, consulting the zoning definition by the master plan to see if the transformation was allowed. Then to the field survey, the observation made live when we were there, and according to the criterion of diversification, so to select areas that were as much as representative of different contexts in a gradient from the urban to the rural. Now we will expose some of the nature-based solution proposal to adapt both to the flood and to the urbanite island. Actually, we didn't find common areas that needed primarily to address both risks together, but we choose representative areas highlighting how they can be multifunctional and so provide co-benefits to both the risks. In the case of the flood, we decided to show you the proposal for the industrial area that is located in the northeast periphery of Temuco. And from the field survey, this area appeared to be a major agri-food center for South Chile, the Vega Modello Temuco, so with a very strong commercial role, not only for the city, but for the entire region. In this case, the intervention proposal was proposed with the aim of not altering the land use, original land use of this area, and to increase the efficiency both in environmental terms, but also in economic terms. For this reason, since this area appeared structured as a parking lot, we propose to replace the existing pavement, asphalt impervious pavement, with a more permeable one in concrete grass grids that is shown here in the figure to create a permeable parking. This solution that appeared to be suitable technically from in-depth investigations that were led there on site would provide the primary benefit of enhance the stormwater management through the increasing of soil permeability, but would be even multifunctional. In fact, in environmental terms, this would enhance the water quality to groundwater, thanks to the filtration provided by this kind of soil, would ensure ecological connectivity to the surrounding rural areas, and with its greenery would contribute to the regulation of the climate, reducing the surface temperature, so contributing to the urbanite island effect of which Ade is talking. Then other co-benefits are economic and commercial, like simplifying the operational procedures, enhancing the aesthetic value of the place, and so in this case, strengthening the commercial role of this area for the entire city and the region.
Another approach used to prioritize the most vulnerable areas involved 3 different criteria. In my case, the zoning definition from the master plan, the field surveys, and the urbanite island effect values. From this selection, among the 15 different hotspots that I chose, I selected only 4 priority areas, which are shown in this map. Regarding the proposed nature-based solution implementation for the area number 3, I conducted a detailed assessment of the area that shows that it includes a commercial use structure with a large surrounding impervious space, like we can see from this orthophoto, near a residential zone. Given these characteristics of this area, the proposed intervention involves the implementation of a green roof on this existing structure, in order to preserve the functionality of the space while enhancing its environmental performance, like improving thermal and acoustic insulation and the mitigation of rainwater runoff, and at the same time to improve the prestige of the area. The table in this slide outlines the main characteristics of the difference between the extensive and intensive green roofs, which can support the future planning of these green roofs. And at the same time, this solution is ideal in a both technical and economical way, because it's aligned with the national regulations, such as the Green Roof Standard promoted by the Chilean Ministry of Housing and Urban Planning. So to conclude this presentation, we wanted to highlight the key aspects that unify these two research projects. In particular, our findings confirm the urgency of intervention for both study risks, as they are priority issues from a monitoring perspective. However, beyond analyzing the context of both Temuco and Padre Las Casas, our research focus on the development of a methodology that is as replicable as possible, even in different contexts and settings, and that follows a so-called bottom-up approach for and by the citizens. This last point is one of the aspects that we value the most, because the success of these solutions largely depends on the close collaboration with stakeholders, with local authorities and communities. These entities have already been involved in our project, as said at the beginning of this presentation, and will continue to play a crucial role in the technical, economical, and social evaluation of these measurements. To achieve these, specific and detailed indicators will be needed to monitor the benefits obtained, along with the development of an integrated urban plan, including the enhancement of existing urban stormwater drainage system and improved temperature monitoring. So to conclude, we would like to highlight the importance of collecting efforts in mitigating this type of environmental risks. So here we have the bibliography, and thank you for the attention.
Thank you very much. It was nice to see your work one more time. So now we have time for questions. I'll open the floor to our attendees, both online and on site. Matt.
Thank you for the presentation. It was super interesting. I was quite curious about the benefit transfer method, and I was wondering if there is already any guidelines or a set of criteria or suggestion, also from your experience in Aveiro, about how to transfer and adapt the method, considering the social, cultural context and the economic context. So values can be interpreted in different ways and are different depending on the social cultural context we are in. So I assume that when we have an equation like the one you proposed, we have to evaluate how to adapt to a specific context. Is there any reference or suggestion how to do that?
Yeah, actually, yes. There are some sources like publication papers, whatever, but I'm mainly using one guideline that is Brander from actually I don't remember the year, but I can share the reference, and is exactly like an explanation of all these benefit transfer methods, and showing how to deal with all these challenges in transferring in a correct way, and how to actually consider all these context-specific variables and how to deal with that. Okay. So it's I would suggest, like, if for who is interested, to start reading, and it's quite simple. I'm not saying because I studied that, but yeah.
Thank you. Super interesting. Thank you.
Have other questions for the floor? And I have one for actually a little bit for everyone, but let's start with Ludovica and Adelaide. I would like you to comment on the importance of the field work. So you first modeled the expected problems related to flood and heat, and then you went to the field and check whether the priorities that appear from your maps basically also, let's say, hold once you are on the ground. Once you were on the ground, actually. So I was wondering if you could comment on any surprises you had once you moved from the virtual world to the physical world, or any other lesson you may want to share about the what you learned through your field work. And by the way, I also take the opportunity to say, especially to our future students, that their work in Chile was supported by our scholarships, which has been awarded to virtually everyone who is interested in doing a thesis abroad, both through the Talete program, also outside it. So Adelaide and Ludovica, any wisdom from your side?
So from my point, among the 15 total hotspots that I selected from the simulation, the field survey was very, very important because, for example, one hotspot, one area, I saw that the area was private, so we couldn't go inside of the area and see where to put and implement an MBS, so or see where our proposed implementation were suitable for example, the size of the street or the size of the structure, like the proposed one, the commercial structure of my area that I show in the presentation. So yes, the field work was very, very important.
If I can add something, in my case, the strength of the field work was even to develop the input for the model, because the land use land cover map, the parameter that we selected were decided through an iterative procedure to reach the real experience that we had the chance to see while being there. So if we saw that the street was not so impervious as the model came out, we adjusted the parameter to make the model work as it should be. So this enabled to create a model that was as much as realistic as possible, and even the dialogue with the communities was important for this, for the prioritization of the areas.
Thank you. You want to comment on this?
Well,
if you wish.
I can say in my case also, like when I start working with this kind of modeling, what I realize is something is when you run the model and you're behind the computer and you don't know anything about what's around and the land use and the context. And when you then realize where, like the area that you're focused for your analysis about, like that you are aware about what's around, and you can probably have, as already said, like, okay, maybe it's not all the same, so you can actually prioritize some areas and you can look at this, observe how is the reality. And then it's easier when you have then to discuss, because of course modeling is like simplification of reality, but then at least you are aware of all the limitation and you can discuss properly, I would say. That's very important.
Thank you. Any question from the floor? Usually I can exercise some pressure on my students, but they all did my exam already. There was a question there, I think. You have a question? That works. Hold on one sec. Do we have a mic? Okay, go ahead. We will. I will repeat if needed.
Start, we are going to propose some ideas to defend the environment from this, but how the public administration or the private population can take your proposal?
Okay, so how to put in practice the kind of analysis?
Yeah.
So how can I use the output in the end?
Yeah, and how the local population take the output, the output.
Well, that's a big question. Well, so I don't know if you all hear the question, but it's more like how we can, with our outputs, I mean, for also the other two presentations, I would say, how we can actually use, and the local population can actually use this kind of output of our research. I mean, I can start replying and then maybe I can give you the floor. So there are many options. First, you can directly communicate with local administrations. And as I was saying, in the end, we can present some scenarios of implementation of these solutions and presenting these co-benefits. For example, in that case, they showed how we can reduce flood risk or like heat island effects. And in my specific case, is more from the recreational and cultural services. So how in the end people can actually use this urban nature. So including all these co-benefits of nature-based solutions, you can actually present benefits and costs of these solutions and propose some scenarios, and the local administration can decide whether it's good or not, or like they can prioritize the implementation areas. So that's more like technical, I would say. But then for like the local population, good practice of nature-based solutions is the co-creation approaches. That means that in the planning, all the planning process of these nature-based solutions, stakeholders, as also local population, are involved in the decision-making process. So they are actually working on preparing workshop, and they work together, or for example, on the perception that they have on these scenarios, and like why they should decide to have a green roof in the school of the neighborhood, or if they like it or not. It's more like about including them in all the process, I would say. I don't know if you want.
Yes, also for our case was very similar, because our idea was to present to the local authorities, like the municipality, some scenarios for each of the areas selected and prioritized, and then with them see where to put an MBS, or if it's suitable for the area selected, and so have talk with them and see with them if it's suitable for the particular area of the city. So in our case, this was a point and an outcome of our work, but for time problems and for the lack of time, we couldn't have the chance to build this connection with the local authorities.
Did I address your question? Thank you.
Okay.
Any other remarks? We have one. This side.
I have
Thank you both of the presenters. It was very interesting topics and it was very interesting presentation. Just a curiosity, like for the assessment of ecosystem service values and benefits, like you at the final map, you mentioned that there were some places which have zero values. At that time, what do we mean by zero values? You mean there is no ecosystem service benefits, or it have another meaning? If it is that one, there were no primary assessments done before implementing the NBSs. I mean, isn't it the before implementing NBS, we should have to do environmental impact assessment or some primary assessments. So after, like, you get my point?
Yeah, so for the first question, as I said, it was zero value. That means that the ecosystem services in recreational, so cultural services, was zero in economic terms. So that doesn't mean that there it was, okay, maybe we don't have the presentation, but maybe I show in the supply maps, the green one, the green spots, there were some lighter green and darker green. So where it was darker, it was like higher supply of that nature class. It was, for example, parks. It was more or less in the city center. And then because we defined that radius, so there was actually the access that people can have to that nature, so to that parks. And higher that distance, the probability that they are going, it's very low. So that's the quality of the nature class that we define. And for example, parks has a high quality normally. And for example, peri-urban, that we basically include like grassland and agricultural like land. There doesn't have a very high quality because I don't think that a lot of people are very keen to go with their dogs or like with the kids playing in that area. So that was more or less the idea. And we try to combine that result on the supply with the economic evaluation. So the economic evaluation was connected to the presence of population that can access to that nature. So it can be that zero value is, okay, it was very far from, for example, from parks, because I only showed the ecosystem services values maps for parks, not for the other classes, because it was the most interesting. So it can be that it was very far from urban parks, but also that there are not a lot of people that can actually go and access to that park. So there are different factors. And I don't remember the second question, sorry.
Yeah, for implementing yeah, you should take into account the primary assessment.
So primary assessment, what do you mean? Because it's not primary assessment in economic terms. Because before I mentioned two methods that we as economists use in assessing ecosystem services in economic terms. And they are primary and secondary methods. The difference, that's a difference than doing some kind of preliminary assessment when you have to implement nature-based solution scenarios. But that's what you have to do. but it's not only economics.
Thank you. I think we have a question from someone online, and judging from the first line is for Ludovica and Adelaide. Can you read them? Can you read the question?
I read the question. Okay. Regarding the parking lot nature-based solution in Chile using a more permeable pavimentation, how was the ecological connectivity aspect evaluated, if it was? Well, this proposal, this intervention was proposed since the area, this industrial area, is located at the edge of the urban environment towards the rural environment. So to put a more green space would clearly enhance the ecological connectivity. Since the ecological connectivity and the increase of biodiversity was not the primary issue addressed by this solution, we didn't evaluate it in depth, but we proposed some indicators to monitor all the benefits and eco-benefits. And in this case, we proposed to evaluate the increased rate of biodiversity in terms of birds, in terms of different species of animals, or even plants. But actually, we didn't think about it in depth, because we investigated more on the primary issue that need to be addressed, so the stormwater management.
Good. Thank you. And I think Melissa.
Okay. My question was on the primary methods. If you could give a little bit more detail on what those tools are involved in the evaluation.
So how they are used, or
How
it works actually?
Both, how they work and what they use.
Use in the same way. I mean, the final goal is to have economic value of ecosystem services. The difference is that in what I show and what I employed in my analysis is I use the value from a primary assessment, and then I use and I applied and adjust in this transferring method on my case study. In the other case is primary. That means that you're going to develop the economic assessment in that policy site. So that means, for example, as I said, you can, for example, develop a contingent evaluation or choice modeling in which you're going to prepare a survey, and you're going to have a sample of people, and you want to know, for example, the value of the willingness to pay of people for the improvement, restoration of wetland in reducing flood risk mitigation, flood risk in that area, for example. That's a primary evaluation. So you ask directly people, hypothetically, because it's choice experiment or contingent evaluation, how can be this change in the ecosystem services? That's an example.
Thank you.
Massimo.
Good afternoon, everybody. A question for you, Carlotta, and another one for the two students. How to integrate this methodology in the private sector interest? For instance, in due diligence for great investors, real estate, renewable energy sources, plants, etc. I'm really interested in having some insights on this point. If you are if you see or you are studying the future perspectives in application of this point, because adding value to an investment in terms of economic stable and sustainable value, paying attention to the ecosystem service is relevant for a lot of companies in business sector. This is becoming an item of evaluation. The second question for Ludovica and Adelaide is about the application of the studies on the methods in terms of risk assessment for defending population from risk of flooding, etc., in a massive behaviors. How to translate the analysis and the risk assessment into suggestion for public massive behaviors, how to prevent risk. Thank you.
So tough questions. Good luck. Carlotta first.
It was a good question, actually. So we are actually working a little bit on real estate values related to improvement of ecosystem services in urban areas. We have some modeling. So that's interesting, actually, because it's highly connected to gentrification. So we are normally going to improve some urban natural areas. Then we saw how prices are increasing of housing, and then like others socioeconomic factors that can be connected to that. I'm not specifically connected to the second part, so the investment on this field, but I do believe that we can already show how it can be the trend of this real estate housing. So I would say that there is a big opportunity in there.
Just to make you understand better, we are doing due diligence in the environmental part and great investors, and they are interested in the component of sustainability in middle long term, not only in terms of the next 2 months or 2 years, but 5 years. What is the increasing value, not only in terms of economic value for trading plants or buildings, etc., but also in terms of more livability of an area, more cultural, recreational livability, I mean. So it's a more complex evaluation system of criteria that is coming inside the list, the task list for the investors.
Yeah, and that's, for example, is I would say when we work with scenarios, we also work with future scenarios of for example, climate change. And that means, like, for example, in air pollution or other kind of indicators. But for example, like in air pollution, then we are going to assess the health impact in the future. And that's then with the nature-based solutions implementation, we can also assess the future impacts. So it can also be extended not only at the present condition, but also at the future.
Are you ready to take the second part of Massimo's question?
Thank you for the question. And actually, the strength of this method, the risk assessment method, is that it evaluates the risk not only identifying the areas where the runoff is concentrated, but allows for the analysis of the vulnerability and exposure factors. In this way, thanks to this in-depth analysis, it's possible to identify which are the criticalities, such as for the vulnerability factor, we studied which are the areas where the materials of the housing are not so good for to resist to a flood. So intervention in terms of to react to the flood is to maybe strengthen these materials, to convert them, and to strengthen the resilience of the city in this sense. So use materials that are more suitable and things like this. The fact is that the vulnerability analysis allows for the identification of the criticalities that are in the cities, and so which are the areas most exposed and most vulnerable. So not only to work with adaptation measures in case of flood, but even to prevent the damage due to a potential flood.
Thank you. Any other questions?
My question was, I was wondering whether there are some benefits that are assessed more often than others, because we are talking frequently about multi-benefits assessment or of nature-based solution, and I don't know if my research is somehow biased from my background, so I can easily recognize and see the environmental benefits of nature-based solution related on water, but I was wondering whether it's the same in your opinion, or if so there are some benefits that are more frequently addressed than others.
That's for sure. And yeah, for example, in these recreational aspects, there are more like primary studies, but mostly primary studies evaluations are very like specific located, so they maybe cover like a small area, and when you want to work like a wider scale, it's always nightmare. So that's why we are then gonna use these benefit transfer methods, so it's less addressed, I would say, a wider scale. Flooding, heat, stress, water quality, air pollution, they are definitely more studied, I would say. But you know, there are different aspects you can always take into account. So there's still a lot to do, I would say. So I would stress to continue working on this multiple co-benefits assessment, because it's very important. And I would say, like, for more like health and health impacts, for example, for the air pollution, they're wide studied. But for example, in terms of mental health, it's very tough. It's very low literature on that, for example. So.
Thank you. Any other questions online? No, just little hearts. On site? If not, then I guess probably not in Rome, but in Trento is already past dinner time. So I think we can bring this first seminar to a close. Thank you to all of you for attending, especially our three speakers. And don't forget to come back to the next session. That will be
27.
March 27.
March.
Okay.
Before finishing, Guido recommended me to remind everybody that behind this structure there is the work, the hard work of our steering committee. So special thanks to Marta, Susanna, Anissa, even me, the working team. And we are expecting from you support in spreading the results, and why not collaborating in the next editions. Thank you.
Please, for DCAM students, remember to sign your presence so we can keep track for your credit. Okay, and see you in some weeks. We will update all the materials you saw today, the slides, in the online platform, and also with some references that were mentioned today. Okay, thank you. And thank you for everyone also online. Thank you, Adelaide and Ludovica.
Ciao, grazie.
Thank you.
Ciao.
Grazie a tutti.